Hi everybody! Today's episode of Time-Lapse Devlog will be unusual because yesterday, May 11th, I messed up with settings for Open Broadcaster, so I recorded 10 hours of video garbage. So now I will explain what I did yesterday, and that's it. First, and the most valuable feature that I'm proud of is cache pre-calculation for artificial intelligence. Uh, it works like that. Let's look at one of the levels of the game. It's level 4.1. Now we are running it without an optimization. So let's look how much time it takes for the artificial intelligence to make a move. So I know that it will take about 26 seconds and it's on PC. When I compiled it for WebGL, it's unusable because during the calculations the algorithm exceeds available memory limit, so it's end up just crashing the WebGL application in browser. So in the version 17 of the StoneDrop, you wasn't be able to play level 4.1. So now we see that a turn takes about 30 seconds, and during this turn artificial intelligence scanned through more than 9 million of different game situations. Let's allow the artificial intelligence to use pre-calculated cache. Restart the level, and now we'll make the same move to provide the same situation to evaluate for the artificial intelligence. But now the turn is made just within 1.7 seconds. And during the calculations, only 21,000 of different situations were evaluated. So now let's look at some theory behind the artificial AI logic. Here I depict simplified graph of all possible situations for some level, and we see that from initial position we have 4 variants to go. Then the count is magnified by 3 in this example, and later it also increases, but then toward the end of the game, when all the cells are occupied by the stones, the number of different possible situations drops down. So the ideal artificial intelligence have to scan through all these situations to make the first turn. It took a long time, so I came up with an optimization where in other application, in my case it's LevelSolver, in other application I pre-calculate all evaluated values for some ply turn. For example, let's make it for the second turn. I pre-calculated all evaluated assessments for these situations, and when the artificial intelligence started to scan these tree, it scans only to the second turn, so it have to scan only this number of situations. It doesn't have to go beyond this barrier because every assessments from these situations are aggregated in already pre-calculated cache. So after we cross this barrier, we have to compute all possible situations without using cache as before, but because we are starting from one particular situation, the number of possible outcomes drops down dramatically. So basically, my estimation is I look at all these situations and divide them by the number of possible situations on the turn where I have to start run previous AI algorithm without pre-calculated cache. So it was the theory about cache pre-calculation. Look at how it works in practice. So here is my LevelSolver, and right now I have an option to pre-calculate cache for all story levels. During this process, it scans all story levels, and if number of free cells is too high, we evaluate how much situations are in this level, and if this number exceeds some threshold, then we decide which turn we have to pre-calculate. And the result of this calculation is a bunch of files. They store all values from this graph. All values for these situations are stored in such files. They don't took a lot of space on disk, and I know how to reduce space usage by 30%, and I will implement it later. But now, for example, the cache for level 4.1 with about 20,000 situation takes about 234 kilobytes. Let's look at the result of pre-calculation. So now we can see how many situations are for the specified turn number, and the algorithm decided that it would be profitable to cache all situations from the turn with number 7. And now it's in the file, and when we start Unity with ideal artificial intelligence, it loads the file, and we can look at the log. So now we see that ideal AI algorithm have found cache with 19,952 pre-computed values. So the results are pretty impressive. Right now, even Google Chrome runs that level flawlessly. So if before that optimization all browsers crashed at level 4.1, right now they process it correctly, and it took less than a couple of seconds to make first turns, because number of situations that we have to evaluate drops down from 9 millions to 20,000, and I'm happy with that results. The next feature I've implemented is for the LevelSolver now. LevelSolver now can assess if somebody who has a winning strategy on the level, if he is able to make a tie. So it's not obvious if you can win on some level, so you have a guaranteed strategy how to act regardless of any actions from the opposite side. If you have that winning strategy, it's not obvious whether you can to make a tie or not, because if you try to play a little less professional, to not to win, it's not guaranteed that the opponent can take it for his purposes and win instead of making a tie. So now LevelSolver is able to do that, and after my re-evaluation of levels from the world 3 in my game, I found that most of the levels that starts from 3, they are impossible to complete because their goal is to make a tie on the level, but in major cases it's not possible for any actions of the opponent. So sometimes you can make a tie, but it hardly depends on the actions of your opponent. I will exclude these levels from later builds, but right now you can try to win. It will be very lucky event if you make a tie on those levels. And the last improvement I've made is I've automated level search. Before that feature, LevelSolver pops out all the levels that were evaluated into one file, and then I copied all the content from this file to Google table, Google spreadsheet, and I've calculated all these percentages for winning or making a tie, and then I manually look through the table and select which levels I have to try. Maybe they are interesting, but now all this logic is happening inside LevelSolver, so the only result is a list of interesting levels that I already should try because the percentage of winning is too low, below the 3% threshold. I hope it will improve the speed of finding new interesting levels, and it won't require manual work anymore, so hope I will find some interesting levels for you. That's all for May 11th. Bye.